All right, so for this extension question, it's really looking at that property that we added to our list of properties back on page 2 of the lesson, I believe. So if we go from A to B, we can split it up and add a boundary C somewhere in the middle of A and B, and then split them into two integrals. So example 5, if I know that the integral from 2 to 7 of a function is equal to 5, and I also know that the function's integral from 2 to 3 is equal to -2, can I figure out the extra little piece from 3 to 7? What would that value be for the same function f? So what you need to figure out is who's A, who's B, and who's C. So from 2 to 7, and then I have a 2 to 3, and then I have a 3 to 7. So hopefully you can see that 2 is your A value, smallest number, and 7 is the biggest number, so that's B. And then I have the C value 3 somewhere in the middle, closer to 2, obviously. Okay, so what do I know then? If I use that rule, then I would know that I would be going from, I just need to give myself a little bit more space. I write too big. Okay, so I would know that from 2 to 7 of my f of x dx, it would be equal to going from 2 to 3 f of x dx, plus then the finishing up from 3 to 7 of f of x dx. And then they gave me some numbers for that. So then I know from 2 to 7, the answer was 5. So I'm going to put that in. And I also know that from 2 to 3, the answer was -2. And it asked me to figure out this piece. That was the one it wanted me to do. So I simply just need to move my -2 to the other side and figure out that the answer to that is 7. So add your 2. And then we can say, therefore, the integral from 3 to 7 of f of x dx is equal to 7. Okay, now the next example, I know yours has a typo. It says examples 8 and 9. It's really examples 5 and 6. So here we are at the next example. So this one tells me if I go from 8 to 1, f of x dx is equal to -10. From 1 to 3 is 4. From 5 to 8 is 2. And so determine 5 to 3 of f of x dx. So notice how they've kind of flipped some of those numbers around. They're not going from small to big on all of them. And that they've got 4 pieces instead of 3 in the previous question. Well, that's okay. We can add a D to our piece as long as it's somewhere in the middle. So we have our A to B. We could put in a C and a D. Okay, in this case, we have to figure out who's who. So what do we have? We would have that A would be equal to the smallest number, which I see is 1. And then I would have C be the next number. Along the line would be 3, and then D would be 5, and B would be 8. Okay, so it doesn't matter how many little pieces you add in, as long as you look at who your lower boundary is and who's your upper boundary. Okay, so really what I need to know then is if I'm going to try and make this be a rule, I know from A to B of my function could then be equal to A to C of my function plus what would be next would be the C to D dx plus the integral from D back to the upper boundary B. So it's okay, we can add in pieces in the middle of this and make up our expanded rule for this property. Okay, so then I'm going to fill this in with what I know of my boundaries. Okay, so I know I've said that A is 1 and B is 8. So if I use this rule I just made, I would need to know from 1 to 8, f of x dx is equal to from A to C. So A was 1, C we said was 3, And then we said C was 3, D was 5. And finally, 5 to 8 would be the last one. So we have to add all of those 3 pieces together to get back to the original 1 to 8. Now be careful, because this one was a little sneaky. This one told me that from 8 to 1, not 1 to 8, was negative 10. So there was another property on our sheet that said if we go from A to B of f of x dx, that is the same as the negative of the reversed order from B to A of f of x dx. Okay, so this negative piece is what I'm going to need to use here, okay, on the negative 10 in order to get my 8 and 1 to be in the right direction. So this will be negative of the negative 10 value in order to get it to go from 1 to 8 is equal to, do I know from 1 to 3? Yes, from 1 to 3 is 4. Okay. Plus, do I know from 3 to 5? No, it wants me to find from 5 to 3. Okay, so that's the unknown. So this one, I don't know. So we'll just leave it in integral form from 3 to 5 of f of x dx. Plus, they do tell me 5 to 8 is 2. Okay, and so I'm going to isolate this. I have 10 subtract 4 subtract 2 is equal to this integral from 3 to 5. And 10 minus 6 is 4. So what does that tell me? It tells me the integral from 3 to 5 is 4. What was the question? The question was from 5 to 3. So I just need to use that same rule we used with the 10. If I'm going to switch my boundaries, right, then I have to take the number and multiply it by -1. So the answer would be -4. Fun little rule. Okay, now let's go back, way back in the lesson. For those of you who are interested in these chapter 8 ones, you don't have to listen. You can finish the video now if you're not interested. Okay, so to evaluate this question, number 3, from 2 to 5, I have a constant 4, and then it's 3 to the power of x. So I could just rewrite this with a 4 in the front. And then it's asking me to take the antiderivative of 3 to the x. We don't know that rule, but I can look here. A is 3, and so it tells me the antiderivative of that is a to the power of x on ln a. So I'm just going to write that out. I have my constant of 4, and a is 3, so 3 to the x on ln 3. And ln 3 is just an exact number, and I'm going to evaluate that from 2 to 5. Okay, so this would be equal to, I can keep that 4 out for now. So I'd have 3 to the power of 5 on ln 3 minus 3 to the power of 2 on ln 3. And so what does that look like? What could I do to simplify this? I could take the ln 3 out as a common factor, and then I would be left with 3 to the power of 5 minus 3 to the power of 2. You can't combine that. It doesn't become 3 to the power of 3. We're subtracting, not dividing. Please do not make up rules. So 3 to the power of 5 minus 3 to the power of 2 is 234. I didn't really need to factor out the ln 3. I could just tidy this all up to a nice answer of 936 on ln 3. Okay, so that ln 3 is the natural logarithm. It's log base so this is equal to log x base 3. So log x is equal to log x, not base 3, sorry, base e. Oh dear, base e. Okay, base e, which we would have learned in chapter 8. Okay, and then this last one looks a little bit like the one that I did for you in number 4. But when we tidy this one up, let's see, 4 to 9, I'd have y squared on y plus y to the half on y minus 2 times y. So notice how the variable is y. It just means then I need my command to be in terms of y. It would be really tricky to do this in terms of x. So this is going to be the definite integral. Y squared on y is y. Y to the half on y to the 1. So 1/2 minus 1 is going to give me negative 1/2 as the exponent. And then this would be, I'm going to leave this one as negative 2 on y for a reason, dy. All right, so let's take the antiderivative of this. So the antiderivative of y is y squared divided by 2. So let's put that as a 1/2 plus the antiderivative of y to the negative half. So I'm going to add 1 to this, which is the same as 2 on 2, which gives me a 1/2. And when you divide by that 1/2, you really get it's 2 multiplied by y to the 1/2. And then this is the new one, minus, okay. So in this part right here, we're going to use the rule that the antiderivative of 1 on x dx is actually ln absolute x plus c. Okay, now that's in one of our x'd out rules that you don't need to know. But we would need to know it for this one. So then this would be minus 2 ln y. And it would be absolute y because we cannot, our y has to be bigger than 0 for a logarithm. And then we are evaluating this from 4 to 9. And I did not give me enough space to write. Tisk, tisk. Okay, so let's see. We would have smaller pen, 1/2 9 squared plus 2 times the square root of 9 minus 2 times ln absolute 9, brackets, subtract, and then we'll do this again with the 4, 1/2 times 4 squared plus 2 times the square root of 4 minus 2 times ln absolute 4. And when we tidy that all up, we get the answer of 69 on 2 minus 2 ln 9. Now that's a positive value, so I guess I don't really need to write the absolute on it. Ln 9 plus 2 times ln 4. Same reason I wouldn't have to do the absolutes. So really what I've done is taken these numbers, the 1/2 9 squared plus 2 root 9, and subtracted it from this piece to get the 69 on 2. And then you cannot combine your ln 9 with your ln 4 because those are different logarithms with different values. All right, so you just leave it like that. All right, that's the end of lesson 11.2. We'll come back for 11.3 is a review of the substitution rule with a new piece to include the boundary rules. So how do you do the substitution rule with a definite integral? So that'll be a lesson 11.3, and we'll see you then.